This is Algebra 1's exam review for Chapter 5. So in 5.1, we looked at multiplication of algebraic fractions, and then we moved on to division, which is pretty much the same thing. We just flipped the second fraction. And so we looked at some strategies where we could do some canceling early. For instance, the 3 and the 30 are going to simplify. You could start simplifying now. This is an x to the first and an x to the second. So this one x will cancel one of these. So that's one way you can do it. But if we are multiplying, we can just multiply straight across the top and the bottom and then simplify at the end. And that may be a strategy that just kind of saves us some mistakes. So that's how I'm going to go about this exam review. But if you know how to cancel things early and that works for you and you get the correct answer in the end, then by all means go ahead and use that strategy. So if I'm going straight across here, the 3 is going to be there in the front. I've got an x and a y. On the bottom, I'm going to have 30x squared. And then at this point, I can start simplifying. So I can talk about that 1x is going to go away. That's going to leave me an x on the bottom still. And the y is going to stay. And then 3 over 30, just a reminder, if you're not good at simplifying yourself, alpha x on the calculator brings up the fraction. Just put in 3 over 30, hit enter, and you get the 1 over 10. Now, I don't need the 1 up top because if I got a y, I don't need to put the 1 in front, but you can. It's not incorrect. And then the 10 goes on the bottom, and I still have 1x remaining. And so there's my final answer. So again, you could have done some of that canceling and simplifying earlier if that's what you like to do, but you definitely don't have to. We can do it at the end. So if I go straight across here, 4 times 3 is going to be 12, and I have A, B, C. On the bottom, 27 times 2 is 54. Some of you might have seen that you can simplify the 3 and the 27 early, or the 2 and the 4. But again, if that's confusing and you're going to make a mistake trying to use that strategy, then don't use it. Let's multiply straight across, and then we'll worry about simplifying at the end. So I'm going to put them in alphabetical order: a squared, b squared, and then just a regular old c. And let me zoom in this so you can see. And so what I'm going to do now is I'm going to cancel this a with one of these, so there's still an a on the bottom. This b with one of these, still a b on the bottom. And this c with this c, that's completely gone now because there was just one on the top and one on the bottom. And then 12 over 54, just punch it in my calculator, it's 2 over 9. So I'm going to have 2 over 9, and then I still have an a and a b on the bottom. All right, so here, 2 times 6 times 5, it's going to be negative 60 with a y still there. On the bottom, 10, and then when we do multiply a y and a y, there's 2 of them, so that's y squared. If you like to keep them separate, you can. And remember, if you were canceling early, you could have just canceled this y with one of these, and then you'd have one remaining, which is what will end up happening for us here. So this 1y cancels one of these. We still have one on the bottom. When we get to our final answer, it's going to be negative 60 over 10. It's just going to be a 6, but let's punch it in to practice using the calculator. Alpha x, 60 over 10. You just end up with 6. So you're going to put the 6 in the top. There's a 1 on the bottom technically, but we don't need it because of the y. All right, and then the last one, we've got 30 times 28. Negative times a negative, it's going to be a positive. 840, a to the third, b. There we go. And then 7 times 120 is also 840. So those will end up canceling. And then I have a to the fourth. So these 3 are going to cancel 3 of these, meaning there's still 1 left on the bottom. And I lost a b here along the way. There was a b over here, so we got to keep that there. And then that will end up canceling the one that's on the top. So the 840s cancel, 3 of the a's cancel with 1 left on the bottom, and the b's go away. So all that's left is an a on the bottom. it needs to stay on the bottom, and I can't leave the top completely blank, so I do fill that space with a 1. All right, which of the following does not equal the others? So this one's already kind of like a fraction. This would be like n over 1. So when I multiply, I'm going to have 5n on top and 8 on the bottom. So those two match each other. This is like over 1. When I multiply, I'm going to get 5n on the top and 8 on the bottom. That matches. This is like 8 over 1. So this one, when I multiply, I'd be getting 40 over n, right? And then that's not going to work. So this one, and when it says explain how you know, if you show your work, then that takes care of your explanation. So this is the one that's different. And let's go to 5.2. So in 5.2, we're dividing. All that happens is the second one flips, and we turn it to multiplication. So it becomes 2 over 6x. Now we do it just like those ones up top. So we're going to get 18x over 18x, which anything divided by itself is just 1. Everything cancels, and your answer is 1. Okay, next one. Leave the first one alone. Change it to multiplication. Flip the second one. 8 times 25 is 200. And you have a y. This is a 10y. Those y's are going to cancel, and 200 divided by 10 is 20. All right, so when we see it stacked up like this, it's a fraction, and this means divided by a fraction. So it says the same thing these do. I'm going to leave the first one alone, so it's 12m over 5. Change it to multiplication, and then flip the second one. 20 times 12 is 240 with an m. And then on the bottom, I've got 5mn. So my m's are going to cancel. I will be having an n in the bottom of my fraction. 240 divided by 5, or you can simplify it, you're just going to get 48 all by itself, and that's going to sit up top. So the final answer is 48 over n. 5.3. Okay, so in 5.3, we started talking about rates. And so a rate is a comparison of two numbers but very specifically with different units. So like miles and hours, inches and hours. So we're comparing two different numbers, right, that are related to each other, but they represent two different things, two different units. Those are your rates. Okay, so for the first one, we're going to calculate the rate here. And we use the word per when we're doing this. So it's basically reducing this down to how much per hour, per minute for one of whatever we're talking about. So what we do is we stack these up in the order that we want to read it. So I'm going to set it up like this because I want it to read in the end after I divide miles per hour. You could do hours per mile, but that isn't really as much of a good, useful piece of information. So we want miles per hour. 150 divided by 2 is 75, and you write this out, miles per hour. And again, that means in 1. So on average, we're going 75 for every 1 hour. Now, we don't know if this was consistent and steady, right? We don't know if they just traveled 75 miles per hour for 2 hours. Could have gone fast, could have stopped, could have gone slow for a little bit, but this is the average here. And that's what a rate is. All right, so then we have inches of snow per hour. So we're going to go 7 inches over 2 hours. Go ahead and divide that, and that's 3.5 inches per hour. All right, and then we also looked at these fractions and we talked about what happens when we end up with a 0 in the numerator? What happens when we end up with a 0 in the denominator? So when we have a 0 on the top, and you can always test this out if you forget which one's which, do 0 divided by anything and you get 0. Do anything divided by 0, and the calculator doesn't like it. So that is your undefined. You can always check yourself. If 0 is on the bottom, it's undefined. If 0 is on the top, it's just 0. So if I asked you what value of x would I put in here to make this equal to 0, you would just say 0, because I'd have a 0 on the top. For this one, you'd say 12, because 12 minus 12 would give me a 0 up top, so on and so forth. But for these questions, they're asking what values of x make this undefined. And so we're looking at the denominators here and trying to come up with a number that I would plug in for x that would create a 0 in the denominator and make this undefined. So I need to know, when does x plus 4 equal 0? Well, that's when x is negative 4, because negative 4 plus 4 would be 0. So right here, this would be when x equals 5, because 5 minus 5 is 0. Okay, for the next one, cannot be undefined. No matter what I plug in for y, I can create all these different numbers up top. I'm always going to be dividing by 5, so it's not going to ever be undefined. Now this one, there is a number we can plug in for x that basically will create a negative 3 for this whole term. Negative 3 plus 3 would give me 0 in the denominator. But how do I figure that out? So I want to know, when does 2x plus 3 equal 0? That's what I want to know. And so I just set up this little mini equation and I quickly solve it. And like I kind of already talked through, this algebra starts to look like what I was saying. I want to know, when does 2x equal negative 3? Because if this is negative 3 plus 3, I do get 0. So now I just divide by 2. And you can leave it like this, okay, or you can change it to a decimal and it's 1.5. All right, and if I plug that back in now, I can check my work. 2 times negative 1.5 gets me negative 3 plus 3 is 0. I end up with a 0 in the denominator, making the fraction undefined. All right, then in 5.4, we started doing these conversions. These were very complicated at first, but we actually did a really good job with these and got the hang of it. So we're going to convert 60 miles per hour. That's what we're starting with. So that's 60 miles per 1 hour. We're going to convert this into feet per second. So we're going to have to come up with some conversions for each one. Now I will give you the conversions for stuff that you might not know. And so for instance, on this one, there's 5,280 feet is 1 mile. You're not expected to have that memorized, but now you have it here in your notes. So if that popped up, you've got it. And so if I'm going to go from miles into feet, I'm going to set that up here. Then I can do the seconds, hours to seconds later. When I set these up, depending on the problem, you have to flip-flop like where this goes. Does it go up top? Does it go in the bottom? We want our miles to cancel so that we're left with feet per second eventually. So in order for that to happen, I have to put miles down here at the bottom. So 1 mile at the bottom, and that means feet goes at the top. So 5,280 feet for 1 mile. And so if I went ahead and multiplied right now, I would have feet per hour. I want feet per second. Some of you know how to go from hours straight into seconds. I'm going to do it in 2 shots here. So first of all, I know hours has to go up top. I'm going to convert it to minutes. 1 hour is 60 minutes. My hours now will cancel, and if I multiplied right now and divided, I would end up with feet per minute. Now I want feet per second. So I'm going to cancel my minutes. I'm going to put them up top. So I put seconds on the bottom. 1 minute, 60 seconds. Now my minutes cancel and I have feet per second. So now I can go ahead and run the numbers. I can do 60 times 5,280 That comes out to 316,800. And then on the bottom, it's just 60 times 60, which is 3,600. And then what you do is you go ahead and divide that. And we're going to get 88. And so our final conversion here is 88 feet per second. Don't leave your answer as this big fraction. Divide and get your answer. And then remember whatever was left, the feet and the seconds, that's going to be your units. All right, same idea here. On average, the human heart beats 65 times per minute. At this rate, how many times does a heart beat in a 365-day year? So 65 beats 1 minute. So we got to go all the way from minutes to 365 days, so for a year. So let's start by get these minutes out of here. Let's turn it to an hour. We know how to do that. 60 minutes in 1 hour. If we're going to go from hours to days, put the hours up top so they cancel. 24 hours in 1 day. And then we're going to go to years. So we're going to go from days, put it up top so it cancels, to years, 365 days in 1 year. And then this will now that I've canceled everything out, this will give me how many beats per year. So when I multiply across, 65 times 60 times 24 times 365. All right, I get this number, 34,164,000. And I get a 1 on the bottom, so there's no division. This is the answer, and this is beats per year. Okay, on to 5.5. A ratio. Okay, so a ratio is also a comparison of two numbers, but where it's different than a rate is a ratio is with the same units. All right, so we have a ratio that needs to be in order to get the exact paint mixture, the right color. And so we have 4 parts of this, 5 parts of this, 1 part of this, and we're going to make 25 gallons of paint. This ratio has to be true whether I'm making 1 gallon or 5 gallons or whatever. It has to be 4 parts this, 5 parts this, 1 part that. If you notice, that's 10 parts total. So you're basically dividing up however many gallons you're making into 10 pieces. 4 of them need to be this, 5 of them need to be this, and 1 of them needs to be this. So the way we solve these is we set up an equation. 4 parts plus 5 parts plus 1 part equals 25. And I can't tell you how many people always put the p on this side too, and then they start canceling things out and their equation doesn't work. There's no p here. This is not a part. 4 parts, 5 parts, 1 parts equals 25 gallons. You can write gallons if you want to. All right, but we're not going to do anything with that. This all now gets combined. They're like terms on the same side of the equal sign. So like I was telling you, there's 10 parts here. And so what we're going to do is we're going to solve this equation, and we're going to take the 25 gallons, we're going to divide it into 10 equal parts. So 25 divided by 10 is 2.5. So each part is going to be 2.5 gallons. And so if 4 parts are pigment, I need to do 4 times the answer of 2.5. And that comes out to 10 gallons. So I need 10 gallons of pigment, solvent. Even if you have no idea what any of this is, you can still solve the problem. Is 5 parts. And remember, there's 10 parts total, so this is basically going to be half. So this should be half of 25 here. So 5 times 2.5 is 12.5 gallons, which again, that's half of 25. And then the linseed oil is just one part, so it's just 2.5. You can always double check yourself. Add these up. They need to come out to our total of 25. Sure enough, if I add 10 plus 12.5 plus 2.5 gallons, I get back to my 25 gallons. I've now split it up into the correct ratio. All right, then to 5.6, we looked at probabilities. Some numbers we need to know. There's 52 cards in a deck. A card is pulled randomly. Calculate each of the probabilities. This is asking you what's the probability of a face card. So you have 4 different suits. Your suits are like diamonds and hearts. So like if you're not going to remember what a suit is, give yourself a reminder. Suits are like hearts, diamonds, spades. And so each one of those has 4 face cards. Or I'm sorry, 3 face cards. So you have king, jack, queen. We don't count the ace as a face card. So each one of these suits has king, queen, and jack. So that means there's 12 total. 4 suits, 3 face cards in each one. So there are 12 face cards in a deck out of 52 total cards. We're going to leave our answer as a percentage. That's what they want. So we do 12 divided by 52. Remember that when you do division like that, it gives you a decimal. You have to move it. Don't say 0.23%. It's not 0.23%. That would be less than 1%. Look at 12 out of 52. That's a pretty good chunk. It's not less than 1%. Got to move it over 2 spots. Okay, and we're just going to round this off nicely to about 23%. Put the little squiggles to show that it wasn't exactly 23, but we're just going to round it off to 23%. All right, so a king. There's a king of each heart. 1 king of hearts, 1 king of diamonds, on and on and on. So there's 4 of those. So we have 4 out of 52. What's the probability of pulling a king if you reach into a full deck of cards? As you go through each one of these, pretend you're starting from scratch. You don't have to take out what you've already done. So 4 out of 52, you go ahead and divide that. Be careful, it's not 76%. That would be right. 76% is a lot, and it's only 4 out of 52. So you're moving this 2 spots. It's 7.6%. We'll just round that up, 7.6 to about 8%. Ace of spades, very specific. Not any ace, just the ace of spades. There's only one of those. There's only one ace of diamonds, on and on and on. So 1 out of 52. So 1 divided by 52. Move that over 2 spots, and it's a 1.9%. So we're going to just call that 2%. And then a 3 or an 8. There's 4 3s, there's 4 8s, 1 of each suit, hearts, diamonds, spades. Okay, so there's 8 total. 8 cards that are 3s or 8s, so 8 out of 52. Looks like this. That's about 15% because it's 15.3. When you slide that over, the 3 is not enough to round that up. So we're going to say about 15%. Continuing with some percent talks here. If there's a 46% chance it will snow tomorrow, what percent chance is there that it will not snow? So when they give these percent of chances, it's out of 100. It's 46% out of 100%. So 46 is not even half of 100. So there's actually a better chance that it's not going to snow. So you do 100 minus 46. Okay, and that means there's a 54% chance it will not snow. All right, 5.7, we actually didn't specifically set aside a day, but we kind of talked about these things as we went through all of this. It relates to everything we were doing. The first question we didn't necessarily specifically talk about. The second one we definitely did. So Sarah participated in a marathon and finishes in the 20th percentile. Explain what that means. So 20th percentile, we're talking about percents again. So 20 out of 100. Now, there might not have been 100 people. There could have been 2,000 people. And so instead of just saying what place she got, because like if there's 10 runners and you come in ninth, it's not great. If there's 2,000 runners and you come in ninth, that's really good. So you can't just go by what place did you come in. The percentile tells you actually how high you finished relative to the whole field. Okay, and so we rate that as a percentage. So top 20% doesn't mean she was in top 20. If there was a million people, she's probably not top 20. But if there's only 25 people and she's top 20, that's not as big a deal. So 20th percentile, better than the rest. So 20 out of 100 leaves us another 80%, right? So she finished better than 80% of the people. Next one, Steve keeps all of his CDs in his backpack. It's got 9 country, 10 rock, 4 jazz, 6 techno, and CDs are so outdated now, so it's kind of funny. But what is the probability from randomly picking out a country CD? So it's 9 country out of your total. So you have to add up your total here. 9 plus 10 plus 4 plus 6. Okay, there's 29 there total. You're going to go ahead and divide that. And it comes out to about 31%. So you're just taking how many of whatever you're talking about compared to the total, just like we were doing with the decks of cards. We're going to do the same thing here, but now we're going to look specifically at some geometric shapes. So suppose you randomly throw a dart at the board. What is the area of the whole board? They're going to kind of walk you through the steps here. Area is length times width, so 2.3 times 2.3. That's 5.29. Area of the circle, pi r squared. The radius is 0.7, so it's pi times 0.7 squared. Remember, we leave pi alone. We're not going to actually multiply pi in our calculator right now. 0.49. You leave pi like an x. So 0.7 squared is 0.49. Leave pi right there. So now the probability of hitting in here compared to the whole thing, just like we've been doing here, whatever we're talking about compared to the whole thing. Whatever we're talking about here is this middle section, which the area was 0.49 pi, compared to the whole thing, which was 5.29. Now we have to divide those. So now we got to be able to handle pi. If you're using this calculator, it's in blue right here. So 0.49, you have to hit the second and then this button to get to it. And we're going to divide by 5.29. And then again, that's a percentage. So you slide that over, 29.0. That's about 29%. All right, then we looked at proportions and cross multiplying. What is a proportion? It's a fraction set equal to another fraction. And we talked about the means and extremes. So you can multiply these two and it's going to equal the same thing that you get when you multiply these two. So 3 times 16 is 48. 4 times x is 4x. You take your two answers and you keep the equal sign between them, and then you just solve that simple little problem. Divide by 4, x equals 12. Multiply here. 27 times 3 is 81. X times x is x squared. Now, we don't really look at this very often right now. We will much more later on. So we actually have to do what number times itself, because remember, this is x times x. So what number times itself gives me 81, and that's going to be 9, because 9 times 9 would give me 81. 9 squared gives me 81. The way that you work backwards is to use the square root, which is right here. Square root And so you would hit second, and then this button to bring up your square root. You would punch in the 81. We're going to know what's the square root of 81. It's the opposite of squared, and then that will give you the 9 as well. And then over here, we look at this when we've got a whole algebraic expression. We're going to write this as a distributive property law. So 7 times this. And notice it doesn't matter which one I put first. I could do the 2 times or the 7 times. Doesn't matter. So I'm going to do 7 times m plus 2. This is how you write it. 7 times the whole thing equals 2 times the whole thing. And then you've got to do some distributing. So 7m plus 14, 8m minus 2. And then you're going to go ahead and you're going to solve that guy all the way out. Now you got an m on both sides. Get rid of the smaller one. So it's 14 equals m minus 2. You're going to add 2. M equals 16. All right, and then we actually used this cross multiplying to solve some bigger problems. So we're going to set up a proportion, and then that will allow us to solve for our missing piece here. So we're going to set up a proportion and solve for x. I'm going to do that down here. So you can set these up all different ways. You can set up the matching sides equals the matching sides. So you could do 5 over 2.1 equals 7 over x. Or you can set them up in the order kind of that you see them, as long as these shapes are sitting the same way. So if this one was going to be tricky and they spin it and the 2.1 was sitting up top, we got to know that it's the smaller side and it matches the smaller side. But let's just set this up nice and straightforward. 5 over 7 equals 2.1 over x. And now we're going to cross multiply there. So we're going to get 5x equals, that's 14.7. Divide by 5, and it comes out to 2.94. So this is 2.94. So what is the perimeter of the larger rectangle? Perimeter is adding up all the sides. It's the total distance around the shape. So 5 plus 5 plus 7 plus 7. Add all of them up. You probably want to write that out so you remember. And that comes out to 24. Area, we're talking about the inside, and you get that by multiplying length times width when we're talking about a rectangle. So it's 2.1 times, now we found the width to be 2.94, so we're going to use that information, and that comes out to 6.174 centimeters squared. Area is always your unit squared because this was centimeters times centimeters, just like x times x is x squared. Centimeters times centimeters is centimeters squared. All right, and then the last question. We have to set up the picture now and then set up our proportion to solve. So Steve notices that a 15-foot flagpole, so we've got a flagpole, okay, that's 15 feet high, cast a shadow. So you got this shadow down, that's 25 feet on the ground. And then a tree next to the flagpole. So I don't have to show this like where the tree is way taller or anything like that. I can do them separately here. So I've got a tree, and it casts a shadow that is 85 feet. So at the very same time, you can look at the length of a shadow and you can use it to help you find some heights. We're going to set up a proportion just like we did before. So 15 compares to 25. The same way, I don't know the height of the tree, we'll call it x. The same way x compares to 85. Or you could have done height over height, shadow over shadow. You will get the same answer. So you could have done 15 over x equals 25 over 85. It just needs to be the correct relation. Notice, when I cross multiply here, I do 15 times 85. That's what I'm doing over here. So even though the setup is slightly different, it's going to result in the same answer. So 25x equals 15 times 18. 15 times 85, which is 1275, and then you just divide to get your answer. So x equals 51 feet.